Good afternoon or morning, depending on what class we're in. This is Mr. Fowl and Mrs. Warling's math class. We're going to try this out and see how it works. So we're going to post this on Cami. You guys are going to follow along with our video. You can pause it whenever you need to, fast forward, or just email us questions because we'll be live while you guys are working on this. So today we're doing solving systems with three variables by elimination and substitution. Your homework is to finish the 7 questions. If you don't finish it, at the end of this video will be an answer key. So the do now is solve the following systems of equations by elimination. So take a second, pause your video, and try the equation out. If you need to, come look at the answer. So to solve this equation, we are going to either get rid of our x's and y's. You can do either way. Either way is acceptable. My suggestion would be, since we have a positive and a negative y, I think it'd be easier to multiply just the top one by 3 so that our y's will cancel. Distribute. This becomes 12x minus 3y is equal to 30. Remember, distribute to all 3 terms. And then 2x plus 3y equals 12. Since we're doing elimination, we just found a way to eliminate our y values. So now we have 14x. Y's are gone because 3y plus 3y, negative 3y plus 3y goes away. Is equal to 42. Got to solve for x now. Divide both sides by 14. And we get our x value as x is equal to 3. So that is our x value. We now need to find our y value by plugging this into either one of our original equations, not to this guy. Because if you made a mistake, you're just making more mistakes. If you plug it right into here or here, you're less likely to make a mistake, so that would be my strong suggestion. I'm going to pick the bottom one because we haven't used them yet. 2 times 3 plus 3y is equal to 12. Multiply, we get 6 plus 3y equals 12. And simplify by getting y by itself by subtracting 6 on both sides. 3y is equal to 6. And divide by 3. Y is equal to 2 as your final answer. There are other ways to do this. You could use your calculator and graph it, but since I said by elimination, this is the only acceptable answer you would get full credit for on the Regents or any type of larger test. Nope, it's recording. Go for it.
There we go. All right, so if you look at the next questions, what about systems in 3 variables? So we now have 3 questions with 3 variables in them. We've got 2x plus 3y minus equals 5, et cetera, et cetera, et cetera. Okay. Now, when we solve this problem in the do now in system of 2 variables with 2 equations, we eliminated one of those variables to make it solvable, right? So in order to do this one, we're going to need to eliminate 2 of the variables, but sometimes you'll be able to do them at the same time, which we'll see as we work on some examples. But for now, if we look at this, and we just kind of have to investigate this for a little bit, okay? What I like to do is I label these. This is equation 1, this is equation 2, and this is equation 3. Our goal is to eliminate one of these variables right now. And if you notice, equation number 1 has a negative z, equation number 2 has a negative z, and equation number 3 has a positive z. So if we went ahead and we added together equations, it popped up again. All right, so here's 1, 2, and 3. If we went ahead and we added together equations 2 and 3, all right, so we have 2x plus 3y minus z is 5, and we have x plus 4y plus z is equal to 12. So we ignore this middle equation for a second. All right, we're going to have 2x plus x, okay, 2x plus x. That'll give us 3x. We have 3y plus 4y. That's going to give us 7y. And these z's are going to go away. So we got rid of the z's. That's going to be equal to 5 plus 12, which is 17. Okay. We can also add together. Oh, sorry. This was 1 and 3, not 2 and 3. I apologize. 1 plus 3. If we then go ahead and add together 2 plus 3, so we just added together 1 and 3. If we now add together 2 and 3, you get 4x plus x is 5x. Negative y plus 4y is 3y. Negative z plus z, those are going to cancel off and go away. And then we have negative 1 plus 12, which is equal to 11. So what we've done is we've turned it from a system of 3 equations and 3 variables into a system of 2 equations with 2 variables. Now it is just like the do now that we worked on, Mr. Fowler worked on a minute ago. So if we look at this, we have 3x plus 7y equals 17, 5x plus 3y is equal to 11. We want to eliminate one of these variables. Doesn't matter which one, so I'm going to go ahead and eliminate the x's. So in order to eliminate them, remember, you have to have the same coefficient with an opposite sign. So let's multiply the whole top one by 5 and the whole bottom one by negative 3. Because what that's going to do is give us a 15x, because 5 times 3x is 15x. 5 times 7y is going to be our 35y. And that's going to be equal to 5 times 17, which is 85. On the bottom, you're going to have negative 3 times 5x, which is negative 15x. You can see right there, we're going to be able to cancel those out. Minus 9y, and that's going to be equal to negative 33. Okay? So by doing that, we can now eliminate these x's. Right? Negative 15x and positive 15x will cancel each other out right there. Okay? So then we have 35y and negative 9y, which is going to be 26y. Extend this a little bit. And then we're going to have 85 minus 33, which is 52. So what we've done is first we eliminated the z's. Now we eliminated the x's, and we've got it simply down to 26y is equal to 52. We divide each side by 26, and we get y is equal to 2. Okay, so there's our first value. Now we just work backwards to find our values for x and for z. Okay, we cannot go all the way back to the beginning just yet because we don't know. We only know what y is. We don't know what x is. We don't know what z is. So we have to go back to one of these two problems that we created where by adding 1 and 3 or by adding 2 and 3. So if we go back to the, I don't know, this one down here, the 5x plus 3y equals 11. Right? And we plug this value of 2 in for y. Then we get 5x plus 3 times 2 is equal to 11. So 5x plus 6 is 11. 5x equals 5, which means that x is going to be equal to 1. So we got our value for y is 2. Our value for x is 1. Now we go back to one of the original equations and we solve for z. So it doesn't matter which one we choose. I'll choose 3 because we have x plus 4y plus z is equal to 12. So we have x plus 4y plus z is equal to 12. All right, we have our value of y is 2, so we'll plug that in here. X is 1, and we plug that in here. So 1 plus 4 times 2 plus z is equal to 12. 1 plus 4 times 2 is 8, plus z is equal to 12. 9 plus z is equal to 12. So that means z is equal to 3. So your final answer that we got is that x is equal to, what was it, 1, y is equal to 2, and z is equal to 3.
Let's tell them go to those questions. Okay, guys, you got 6 questions after that. You're going to pause the video, work on the next 6 or 7 questions. The answer key is attached, so if you get stuck, but in a moment, we and Mrs. Worrell will go over the answer key. So good luck. Tune back in once you're done working on those. Okay, guys, we're going to begin going over some of the answers. I'm going to go over number 1, show you a trick in the calculator that might help you, and then I'll be available the rest of the period, me or Mrs. Werland, to answer any questions you may have. So this question right here, just like what Mrs. Werling did, he looks for letters that might cancel out on their own, so you don't have to actually do all the work. So if we look at this, we see that all of these are 5y's. So just like what he did, I'm going to label my equations 1, 2, and 3. We want to get rid of the y's because we have 5y, 5y, and 5y. None of the other letters are the same, so it'd be easier to get rid of those first. So we're going to do, if we did equation 1 and 2, we would get a negative 10y. We don't want that. But equation 1 plus equation 3, 1 and 3, is going to get us so that the y's cancel. So we're going to line those up just on top of each other. We have negative x minus 5y minus 5z is equal to 2. And then equation 3 is x plus 5y minus z is equal to negative 20. You just add straight up and down, just like old school adding. Negative x plus an x goes away. We have no x's left. We didn't see that was going to happen, so that's a really good thing, though. Negative 5y plus 5y. Cancel. So we have 0x, 0y, so we don't write those, and then a negative 6z is equal to negative 18. Super easy to solve because we want to get z by itself, so we're going to divide by 6, or negative 6, sorry. Z is equal to 3. That is one of your answers. So since that's one of your answers, we can work backwards now and start plugging in from there. Sorry. Hey, you shout out to Mr. Playa.
Hi, guys.
We're recording for tomorrow.
Oh, all right. You're on freeze?
Okay, so we put together equation 1 and 3. We're going to also put together equation 2 and 3 because, again, we're looking to get rid of those. So equation 2 plus equation 3, and that's going to get rid of our y's. 4x minus 5y plus 4z equal to 19. And then x plus 5y minus z is equal to 20. This is also going to get rid of our y's. We decided early on our y's seem like they're going to go away, so we're sticking with our y's. So our negative y and our positive y's are going to cancel again. But this time the z's aren't, or the x's. That's life. That's how it goes. 5x, y's cancel, plus 3z is equal to 1. So now we're here and we're like, that's not good. We only have a z, we have an x and a z. But working backwards, we can take our z and plug it right in here, and that is going to, without you really even realizing it, is going to get you your x value. 5x plus 3 times z. Z we know is 3. Is equal to 1. 5x plus 9 is equal to, negative 1. Subtract 9. 5x is equal to negative 10. Divide by 5. X is equal to negative 2. So we got to go all the way back to one of our original equations and plug in x equals negative 2, z equals 3, and use that to find out what our y value is. So take any of the original equations. It doesn't matter which one. I'm going to pick the first one. Negative x minus 5y minus 5z is equal to 2. We know that x is equal to negative 2. Minus 5y, we still don't know. Minus 5 times 3 is equal to 2. Down a little more. A negative 2 is 2. Minus 5y minus 15 is equal to 2. And just keep working from there. You're going to slowly get down to what our y value is. Kind of strange, but we got this and this are common terms. So you have negative 13 minus 5y equals 2. Add 13, add 13, negative 5y is equal to 15, divide by 5, with negative 5, y equals negative 3. And that is a total disaster. I'm not expecting you to do this every single time. This is a lot of work. If you're taking a Regents, you got to show 99% of this work. But there are definitely ways around this to make your lives easier. Just keep in mind, we made it so our y's canceled. We use that information to find one of our letters, plugged in that one letter to find the other letter, which was x, and plug it all the way back in. And if you're timing me, that was probably 6 minutes, and let's face it, I lost half of you. So let's say if you were awesome enough and picked up a calculator at the beginning of the school year like you were supposed to, which are still available, email me or Mrs. Orland if you need it. If you want to do this in a calculator, you're going to get a new calculator, so you're going to add calculator. We are going to do menu 3. And right here, we should be in good shape. Numerical solve is if you're solving for a single letter. We're not solving for a letter. We're looking for a system of letters. Polynomial tools is if we're looking for just a polynomial. We're looking for x values, really. We're not doing that. System of linear equations. How many equations do we have? We have 3 equations. What are the letters of that equation? Are they x, y, and z? Wow, they are. Your calculator's really smart. Just type it in exactly the way it looks. I'm going to use the computer for this because it's a lot easier to type on that. We got negative x minus 5y minus 5z equals 2. First equation done. 4x minus 5y plus 4z equals 19. X plus 5y minus z equals negative 20. I did something wrong. So, negative 20. There we go. Negative 20. I got to put a negative 20 right here. But look how nice that was. I made a mistake. I knew instantly I made a mistake. But now I know I didn't make a mistake. Your x value is negative 2. Your y value is negative 3. Your z value is 3. The beauty of this is, look now over here. Did you agree with this? Absolutely, we agreed with this. So, long story short, the calculator can cheat for you. I can't watch you do your work right now. The Regents can't watch you do your work right now. So, Mrs. Orland can't either. So, use the calculator to help you to at least check your work. No one should not get at least 1 point on this question, because if you wrote down those 3 numbers, you get 1 point. The calculator will do it for you. So, the rest of the period, you guys are going to work on the rest of these problems. Whatever you don't finish now is your homework, so why not do it? You have 5 questions left, maybe. We are nice enough to give you the answer key, because if you have trouble, maybe the answer key can help you out. So the calculator is not going to really help you much. So try to use the elimination or the substitution method, or use your calculator and show some work. Some work means I need to show some type of putting together the equation. So I'm trying to get at. So if you have any questions, me and Mrs. Orland will be on our individual Google Meets. So please just let us know. Whatever you don't finish is your homework, though. So please let us know if you have any questions. And if not, have a great day.
Bye.
Bye, guys.